Well, good morning, everybody, guys. Welcome to the session in here for today. I hope all of you guys are able to hear my voice clearly. My screen is visible, and everything from the internet point of view is going good. Right, guys?
Yes,
Can I get a small confirmation for this? Perfect. Okay. Good morning, everybody. So, first of all, I hope that the session that we have completed yesterday, I hope you guys enjoyed that session. That session was slightly basic, I would say. Reason that it was basic is, first of all, obviously it was the first session. Second thing is that we have to make sure that we are starting properly from level zero. Okay, so that all of you guys are in sync with whatever we are doing. Now, yesterday there were some topics which were remaining, and I thought that it's a better idea if we don't rush through the coursework, and if we complete it today, because what I feel is that whatever we have to cover up for today, it is something which can be covered up in 1 hour 30 minutes, this Tuesday morning session. So there are two things that are remaining. First is sequence to sequence model, second is evaluation metrics. So these two things are something which I want to cover up, then we will start with this particular portion. Okay, now what I want all of you guys to understand is that sequence to sequence models in itself, it is a very big topic. Okay, I mean, yeah, in sequence to sequence model in general, there are two, what you can say, neural networks. In a very high level overview, I'm telling you this part. There are two neural networks. One neural network is called as encoder, second one is called as decoder. Now, what basically happens over here is that when you give input data which is textual in nature, what is basically happening over here is that that input textual data is encoded in a format. As we spoke yesterday, that machine learning algorithms are something which can just work with numbers. Okay, there is no other option that is available over here. So the same ideology is something that we are going to follow. Okay, the exact same ideology is something that we are expected to follow over here. So what happens is that whatever is the raw textual data, right, that we are getting, that raw textual data is something that you encode into vectors. As I told you, what is vectors? Vector is a numerical representation of the textual data that you are feeding to the model. So encoder, that task of the encoder is to encode the raw textual data which is not in numerical format, and essentially at the end of the day, then there is a decoder whose task is to reconstruct that raw sentence. Now, the problem over here is that when you are reconstructing that normal sentence, it's not that all the time this perfect scenario is something that will take into consideration, like that will happen over here. It is not like that. So let's say that there is X sentence, you will not get exactly X, you will always get X dash. Okay, and obviously, as we do in our predictive models in classification, regression, our main activity or our main aim is to make sure that there is least amount of difference between the data that we have given as input and between the data that has been encoded. Right. So this is the main idea of sequence to sequence model. The reason why it is called as sequence to sequence is because whenever I speak any sentence, like right now I'm speaking a sentence. So whenever there is a sentence that is spoken, in that the word, it's not only about presence or absence of the word. If you remember yesterday, I told you that there is something called as lexical processing, which just takes into account presence or absence of a word. Okay, that is lexical processing. But it's not only about lexical, there is semantic, there is syntactic. So syntactic is basically something which refers to the grammatical mistakes, and semantic is something which refers to the sequence of the words. So there are a lot of situations in which the exact words, but in different combinations, have totally opposite implication. Is it possible for you to do X? Will X be done by you? So in the first sentence, there is a request. In the second sentence, it's kind of an affirmation, right? So the same words arranged in a different sequence may carry different sentiments, different meaning. And that is why in sequence to sequence models, we take into account the relative positioning of words so that we can derive the meaning out of it, right? So it is very useful for text summarization problem, it is very useful for machine translation problem, it is very useful for conversational modeling like chatbot. So almost 1 to 2 years back, like from 2022 to 2023, uh, in IT industry, there was a huge surge or huge demand of people who can actually work as data scientists with chatbot creation experience. So there are different libraries in Python, especially RASA, RASA. It's a library in Python that can really help you to create interactive chatbots over here. Okay. So now after this particular portion is completed, let's try to see the same thing is mentioned over here, encoder decoder architecture. Now I didn't tell this point to you guys yesterday, but the thing is that I want to cover live coding for sequence to sequence models, but it's a very lengthy topic, to be honest with you. I mean, we can spend total 2 hours of our session in live coding sequence to sequence model. Hence, I will maybe give you some reading material or some coding material which already has the codes for it so that we can focus our attention to the other part. So basically, first you create a neural network for encoder, then you create a neural network for decoder, and then you run the iterations. So again, it's one of the examples of generative AI. In that, what is basically happening is that so in that what is basically happening over here is that it's kind of generative AI where the encoder is encoding the raw data and decoder is basically responsible for decoding the raw data that is being received, and there should be like they should be as similar to each other as possible. Okay, so that is basically something which all of you guys are expected to be clear with. So I have added over here, and for encoder decoder architecture, typically with NLP problems you need RNN. So since you guys are already professors, already teaching these courseworks to the learners, so I hope you are aware of what is RNN. So RNN stands for recurrent neural networks, and RNN has two modifications. First is called as LSTM, long short-term memory. Second is called as GRU, which is gated recurrent unit. So we don't have that much bandwidth that we can discuss RNN, LSTM, and GRU in detail. But these are the models which can be used for extracting sequential information in the data that is available. What is the meaning of sequential information? Sequential information basically means that, let's say, textual. So the sequence in which words are arranged, it carries a meaning. Let's move ahead to the next point, point number 2. In that particular portion, what basically happens is that, let's say, stock market data. So the price of a particular stock at 915, 916, 917, 918, 990, there is a pattern in that, right? That it is kind of trying to show a pattern or kind of trying to show a behavior which you are expected to capture. So in all the situations where you guys would be able to identify sequential nature in the data, there this encoder decoder architecture is something which can be really fruitful. Is it making sense to all of you guys? Everybody? So this is what encoder and decoder is. So encoder reads per input sequence one token at a time, updates the hidden state. Now what is hidden state? For that you have to study RNN, recurrent neural network. In that there are three gates in LSTM actually. There is input gate, there is forget gate, and there is output gate. Whereas in GRU there are just two gates, update gate and reset gate. That's it. So obviously you need to have some basic level of background in that, then you can create sequential models with the help of that architecture. Okay, so I have mentioned all of these details in the content that is basically available over here, right? Everybody guys, so take 30 seconds of your time. Do let me know if I can help you with anything. guys. Now, after this particular portion is completed, let us try to move ahead with the next part. So now after this is done, the most important portion that I want all of you guys to be comfortable with, it is kind of revolving around a portion, or it is kind of revolving around a scenario that all of you guys should have some basic introductory level idea in a lot of concepts over here. So if you know encoder, if you know decoder, after that you train the data. Training process is something which I feel you already know, that you give the data to encoder, it will encode the data, the raw data into sequences. Then there is decoder. After that, in decoder, what will basically happen is that it will try to reconstruct the normal sentence from that particular portion, and depending on that, we will kind of try our level best to make sure that it is in proper sequence, right? So now after this particular example, after this particular portion is done, attention mechanism is something that you can read, it's not there in your coursework. Let's try to read about the evaluation metrics. So we already know that for typical classification, typical regression models, there are evaluation metrics. Okay, so there is precision, recall, accuracy, F1 score, and whatnot. Okay, and whatnot. So to evaluate the NLP models, you cannot evaluate NLP models in which the textual data is being summarized or being generated with these metrics. Is it possible? No, it's absolutely not possible, because the output is not discrete, or output is not continuous. It's totally different in nature, and hence we need to arrange for different evaluation metrics. So rogue, blue, meteor, these are the three evaluation metrics that are available over here, so that we can evaluate the generated textual data. So let's see the full form of rogue. Rogue stands for recall oriented understudy of gisting evaluation, and there are different variants of this rogue, by the way. Again, we cannot go into that much depths of everything because we have limited bandwidth, but I have deliberately added it over here so that later on, if you are doing your self-study, I totally will assume, I'm assuming that you guys will do your self-study, you guys will read your research papers and everything. So in that, there are different variants of rogue, like rogue N, L, and W. There is a very small overview about rogue N, L, and W that I have added over here. So as you know, it's recall oriented, means recall is something which we will take into consideration. So recall, if you know, it gives you idea about false negatives or type 2 errors in hypothesis testing, right? So it measures the n-gram. Since it's rogue n, there is n-grams in textual preprocessing, which is continuous sequence of n terms that we take into consideration. So what we are basically doing over here is that we take this rogue n into consideration. Everybody guys, please be very clear on this particular part. Okay. Now, after this particular portion is completed, this is the formula, you can read that later. There is rogue L, which is taking the longest common sequence, LCS, between the system of input data and output data. So it takes into account sentence level structure similarity, and it identifies the longest common sequence in both generated data and the input data that you are giving. And third is rogue W, which is a weighted version of rogue L, which adds a weighting factor to penalize shorter matching sequences, and obviously then to reward the longer matching sequences. Okay. So I have just added introduction to all of these points over here. I have underlined all of these points so that when you're reading, you can take reference to this particular part. Just 1 minute. Share. And here we are having document. I have already given this document to you, and I was expecting that you will slightly go through this particular part. But I understand if you were not having that bandwidth to go through it, you can read it right now. Sharing is okay. So after this is done, what I wanted you to understand is that there is rogue, which is recall oriented study. Second thing over here is there is rogue n, which takes n grams, log l, which takes longest continuous sequence, sorry, common sequence. And since it's taking longest common sequence, what is happening is that it is taking the structural similarity of the data points into consideration. Okay. Now let's try to move ahead with the next part over here. So after this particular portion is implemented, let us try to move ahead with the next part over here. So what I wanted you guys to understand is that there is something called as BLEU, BLEU, which is bilingual evaluation understudy. So it is based on precision. Okay. Then it is there is something called as brevity penalty, and then there is combined score, which is multiplication of brevity penalty and this particular portion or this particular part. Okay. So now after this is done, let's try to see what is it. It is a precision based metric. What is precision going to give you idea about? Precision is something which gives you an idea about false positives or type 1 errors. Okay, it is basically something which gives you an idea about false positive or type 1 error. Now after this is implemented, right, after this particular portion, after this particular situation is implemented, let us try to move ahead with the formula. So there is blue one, which again it measures the n grams of generated text that appear in the reference text. Here also the same part is available. Here it's just precision based, right? 30 seconds for all of you guys to move ahead with this. Now after this is done, let us try to move ahead with the next portion, or let us try to move ahead with the next situation over here, everybody guys. So now after this particular portion is completed, next part over here is brevity penalty, which introduces, which is over, like, which is present over there to penalize shorter sequences, right? So when C is greater than R, what is C? What is R? R is the reference or the minimum sequence that we are taking into consideration, minimum length of the sequence. C is the sequence that is being observed. So if C is greater than R, if it is moving beyond our threshold, then there is no problem. But if C is less than or equal to R, then we have a penalty term called as e raised to 1 minus R divided by C, right? Now, after this is done, what is basically happening is that R by C, okay, it is always greater than or equal to 1, meaning that this will be a negative number. I mean, raised to, it will be a negative number, means e raised to something negative is in decimals. So this will reduce the penalty, I mean, reduce the weight associated with respect to that parameter over here. So you multiply both of these two things, and then depending on that, a final score is something that can be observed over here. So I hope you guys are clear with this. Perfect. Now let's try to move ahead with the next part over here. Okay, so after this particular portion is implemented, the next part is Meteor, which is metric for evaluation of translation with explicit ordering, ORS ordering. Metric for evaluation of translation with explicit ordering. So it is designed to address the limitations of BLUE, and it is used to focus both on precision as well as recall. So the first method, which is based on recall, right? Rogue, NLW, all of them, BLUE based on precision. Now it's like F1 score. Meteor is like F1 score. Here we would be using both precision and recall, and we would be incorporating additional linguistic features over here. Okay, so Meteor is F mean into 1 minus penalty. Again, the penalty is there for shorter sequences, and F mean is 10 into P into R divided by 9P plus R, right? So it's not P plus R, it's 9P plus R. So more weightage is given to precision over here because it's there to address the limitations of BLUE. So BLUE precision is going to have a major impact over here. Okay, 9 is to 1. So that is something that you can read, take a minute for this, and then I think all the metrics are done. And yeah, we will move ahead with the live coding session then. So 30 seconds for you to read about this, and then we will move ahead with the comparison in which situation you have to use Rogue, BLUE, and Meteor, and then the live coding part. What are the functions that will help you to get all of these metrics? So now after this is done, I think we should it's high time for us to get started with the live coding session. So it's prominently for text summarization, which effectively measures the Recall, this is used for machine translation problems. Okay, providing precision, and it attempts to address the shortcoming of blue by having a balance of precision and recall, and there is linguistic detail, attention to linguistic detail over here. You can read it later on when and where required. Okay, and let's try to now move ahead with the live coding session for the evaluation metrics, because I think it is something which we can easily complete in a few minutes. Okay, so what we have is importing important libraries. Okay, so what is happening over there is import NLTK from NLTK dot translate dot blue score, import sentence blue, then there is smoothing function, second part. Smoothing, okay, spelling SMOOTHING, okay, smoothing function, perfect. Then from rogue underscore score, import rogue underscore score, comma, scoring, and import numpy as np, import warnings, warnings dot filter warnings, ignore. Then no module nltk.bleu, it's not au, it's bleu. No module name rouge underscore score. Okay, so let's try to install this. Installing rogue score. Exclamatory mark with install rogue score. And then, okay, it's installing this particular part. Then the better idea is to restart it. Okay, always restart the kernels after this part, and then you can have this portion. I think the, what's the issue from rogue scorer, RER. Okay, so this is the code, exclamatory mark pip install rogue score. If you are using this for the first time, you will need to install it. And yeah, this is basically the importing of the part. Then we have updating the uh, required corpus of words. Okay, so it's nltk dot download, and here we have wordnet, and similarly we have nltk dot download, and here we have punkt, punkt. So these are the two things that we would be needing, and it may happen that it's already up to date in your laptop, but it is our responsibility to make sure that it's up to date. So every time you have, it's already up to date, and even this is already up to date, but it's our responsibility to make sure that the NLP packages with which we are working, they are up to date. Okay, take your point for this and do let me know if you are having any questions, doubts, or concerns on this. So now after this is done, let us say we will do one thing. We will give example of generated and reference sentence. Okay, so we have generated underscore sentence is equal to the quick brown fox jumps over the lazy dog. Okay, reference sentences, reference sentence is, we will do just one change over here. Copy it. There is just one explicit change. Jumped over the lazy dog. Okay, we just made one change from jumps to jumped. Now you have convert sentences to list of words. So generated tokens is equal to NLTK dot word underscore tokenize, and here it's generated part, and you have one more thing, reference tokens is equal to this particular portion. Now after this is done, we have blue score. So in blue score, what we are doing is, first of all, we are initializing the smoothing function. It's your homework to search why this smoothing function is needed. Everybody guys. Blue score is equal to sentence underscore blue. In that there is reference tokens, then there is generated tokens, and then there is smoothing function equal to smoothing dot method. Smoothing dot method. And this is something which should help you. Okay. And finally, after this, you have print blue score, which is this particular part. So our blue score is coming out to be 0. Okay. Similarly, we will have rogue score, scorer is equal to rogue underscore scorer dot ROUGE scorer rogue 1 comma rogue 2 comma rogue L. So L, you know what is that longest common sequence? Do you know what is rogue 1 and 2? Which one is n-grams and which one is weighted one? Search about that. That's a research homework for you guys. Use stemmer is equal to true. So it will stem the data. Then scores is equal to scorer dot score. And here there is reference sentence, generated sentence. Okay. And then you have print row scores. Let's score. So precision recall F major, precision recall F major. Here you are getting almost one. Okay. 30 seconds on this, everybody. Then we will try to move ahead with the next part.
So that means rogue score will come out in terms of precision, recall, and F1 score.
Absolutely, yes.
Okay.
Yes. And that too for all the rogue methods, rogue 1, 2, and 3. Right? So n-grams, L is for longest common sequence and W is for weighted. So here L is the longest common sequence. What is rogue 1 and 2? You search which one is n-grams and which one is weighted. And yes, to answer your question, it will come out in this particular format. It's your choice. If you want, you can just extract precision also out of it. It's a dictionary, right? So from that you can just extract precision value and that should also go. And last thing would be meteor.
So one more
M
question.
yeah, absolutely.
Uh, if we are doing abstractive summarization,
Hmm.
will rogue be a better evaluation metric to judge the summary? I don't
If you
think.
are no, it's blue because see use cases. When you are doing
Mhm.
machine translation and text generation tasks, right? In that scenario, this is there. For text summarization, it's rogue, right? But when you're creating abstract summary, it's like obviously text summarization and you also generate the task. So I think Meteor should be one that you use, right?
Okay, but what I am analyzing is in all these up till now we have studied rogue and blue. The
Mm,
concept is regarding the uh, about the there is no semantic analysis whether we are finding out the actual meaning of the content, and what we are generating is the summary, whether that meaning is there in the summary or not. We are not going to
exactly,
evaluate with the help of this, right?
exactly. Semantic is not done. Here we can
Yeah.
do what was that presence or a lexical and syntactic, but not semantic.
Okay.
Okay, yeah,
Okay.
correct. There are other metrics available as well. Since this is available, this was there in your course curriculum, I have included just these three things. For semantic analysis also there are evaluation metrics that are available. Okay. And last but not the least, let's try to have meteor, right? MEDEOR score. Scorer is what we will have. Rogue scorer, this total part. Okay. Then, or let's create a function for this. Def meteor score reference comma hypothesis, and what is going to happen over here is reference is equal to a space dot join reference hypothesis is equal to space dot join hypothesis and return nltk dot translate dot meteor underscore score dot meteor underscore score, and here you give reference comma hypothesis. Yeah, invalid syntax meteor underscore score dot, right, and then there is a single bracket at the end. I think this should work. Now we have getting the meteor score with the function that we have created by our hard work. Meteor is equal to me meteor underscore score, correct, which has a lot of parameters. Here there is reference tokens, there is generated tokens, then you have print meteor score translate. Mm, hypothesis accepts pre-tokenized the quick bound functions open the lazy dog. Just 1 minute. Mm, we have given it in the form of tokens itself. Let's do one thing. Let's restart it. This is sentence. These are tokens. This is smoothing, row score, mm, hypothesis, meteor underscore score, its reference comma hypothesis, and then this last part, generated tokens. Just 1 minute. Mhm. Let's do one thing. Maybe this will go. Mhm. Okay, let's try to move ahead. So pre-tokenized hypothesis string table. We have already given it. Okay, you try to write till this point. Let me think what's the issue. Join hypothesis reference. Let's do one thing. Let's have generated tokens again. Again, generating tokens. So NLP.word underscore tokenize. Perfect and word tokenization. This should be in a list. B.word tokenize reference tokens. Let's run it. Okay. Now let's have getting the score. So score is equal to meteor underscore score. Or let's do one thing. Have we imported meteor underscore score? That's the problem. Let's do it with the pre-written inbuilt functions itself. So from nltk dot translate import meteor underscore score, and here there is one more package which we need to confirm. OMW 1.4. And now let's remove this, and here meteor underscore score we can have meteor underscore score dot meteor underscore reference tokens generated tokens and print meteor score. Yeah, this is the meteor score. Okay, so I think this should wrap up all the things for us. Now, after this is done, let's do one more important thing. So this covers up the first part over here. Now there is named entity recognition, syntax and parsing, word sense disambiguation, and all of these portions. Let's try to do this part. But let's take a small break of 5 minutes. Spelling mistake of translate, yes. Let's try to resume at 11 a.m. 5 minutes break, everybody, guys. Thank you. So let us try to move ahead, guys, with our next part, named entity recognition. So what is basically happening over here is that, let us say that there is a sentence that is being given to you. In that particular sentence, there is definitely going to be a person, right? Some organizations, location, date, time, money, percentage. So in a given sentence, NER activity is basically something which refers to identifying those key aspects or those key parts over here. Right, guys? So take a minute, read this particular part, and then we will try to do the live coding session for this. So there are different techniques. There is rule based, then there is machine learning based, in which there are different models, like there is hidden Markov model, there is conditional random field models, bidirectional LSTM, right? So it can go at any layer, but the amount of time that we have in our coursework, depending on that, I will try to give you a short demo for NER, right? The most important part is you should know what is the meaning of that particular section. So basically, in a given sentence, whenever there are, what you can say, different aspects, right, whatever are mentioned in the second bullet point, person, organization, location, money, so you should be able to identify that with this given section, right? So now after this is done, okay, take 30 seconds for this. So now after this is done, let's do the next part, which is named entity, entity recognition, NER. So what we are basically doing over here is installing required libraries. If you are using it for the first time, you will have to do it exclamatory mark pip install HMM learn, hidden Markov model learn, HMM learn. Then we have, let's restart. This is the code HMM learn. The global chat I've given it to you. Next is importing important libraries. So here what is basically going to happen is import numpy as np, import pandas as pd, import nltk, then from sklearn dot model selection import train test split. Next is from HMM you have import HMM, import warnings, warnings dot filter warnings, ignore. Okay, now let's try to move ahead with warnings, NINGS. Here we have example annotated, annotated sentences. Data is equal to John is. I'm already giving tokenized sentences so that we don't have to again tokenize it. New York City, and here I'm giving P dash PER. So is basically an object. So then here it's green is, then John is from. Okay, New York City is B lock because it's location. Right here it is I lock. Next is again city is I lock. What is B lock, I lock? We will discuss it. Don't worry about it. And after that is done, again the next part that we are having is mm, Mary visited Berlin last week. And here we are having what is Mary? It's a proper noun, it's a person. So BPER. Then other, then B lock because Berlin is a proper location. Then this is O other, this is again O last other. And you can add as many sentences as you want. Okay. Now split into training and testing data. So train data, comma, test data is equal to train test split data, comma, test size is equal to 0.2 and random state is equal to 5, which is just a simple random number. Okay, what's the type error? Test size. And now after this is done, we have create a vocabulary and tag set. So words are equal to set of word for sentence, comma, underscore in data for word in sentence. And similarly, tags is equal to set of tag for underscore, comma, tag underscore sentence in data for tag in tag underscore sentence. Okay. Next is that we are going to have a dictionary for the same part, in which what we are basically doing is word to idx, it's equal to word colon I for I comma word in enumerate enumerate words. Okay, and same thing we are expected to do for tags. So tag to idx is equal to tag for I comma tag in enumerate tags. What's the mistake? Enumerate. Okay. And after this is done, you will convert the sentences into numeric format, then train the hidden Markov model for the entity recognition. And now what we would be doing over here is that we would be converting, yeah, what we will do, convert the sentences to numbers, to numeric format. For that, we will have def convert to numeric, and over here we will have our whatever is the data. X is equal to empty list, Y is for tags, and for sentence, comma, tag underscore sentence in data x dot append word to idx square bracket word for word in sentence, and y dot append tag to idx tag for tag in tag underscore sentence, return x comma y. Then converting to numeric format, extreme y train is equal to convert to numeric format train data. So now we are having almost having our data. We will try to do some slightly more analysis, reshaping and everything, but now we can train our hidden Markov model. So take 30 seconds if you want to read it. Any which ways, this live coding file is basically something which I am going to share with you. So don't worry about that. So now let's try to move ahead with the next analysis, with the next part that is available over here. Okay. So you have to flatten the sequences, flatten the sequences for hidden Markov model training. So X train flat is equal to item for sublist in x underscore tree for item in sublist. And similarly, you have y train flat is equal to then you have reshaping the data stream reshaped is equal to np.array x train, oh my bad, x train flat, and you have dot reshape it. We don't know the number of rows, but we need one columns. And same goes with y train. Okay, and now we initialize the Markov model. Initializing the HNM, HMM model equal to HMM dot multinomial, since we are having multiple classes and components. Components is equal to length of tags, comma, the iterations that we want is equal to 100. And then you have model dot fit x train reshaped, comma, length is equal to length of sequence for sequence in x train. Okay, finally we have our hidden Markov model being trained. Now we will do the predictions from it on the testing data. So take a minute. I think there is, can the input data be in the format of text and PDF file? Absolutely, it can be in the format of text and PDF file, Lakshmi. But then what happens is that we have to spend our efforts in bringing the data into the required format. Absolutely, you can take the data in any format that you want, but then it is us who have to spend the efforts in converting the data or bringing the data into a format such that it can be fed into the model. 30 more seconds if you want to read about it. So now let's try to move ahead with predicting on the testing data and seeing how well the predictions are. Creating a function for prediction where we are having def predict sentence. Okay, and here you have x is equal to np dot array word to idx square bracket word for word in sentence dot reshape -1 comma 1. Next is log prob comma states is equal to model dot decode x comma algorithm is equal to with then you return list of tag to idx dot keys square bracket state for state in states. And finally, testing the performance of the model, where what we are doing is that for sentence comma true tags in test data, we are going to have predicted tags is equal to predict sentence, and you have print sentence dot join sentence print true tags predicted tags. So first is correct, second is correct, third is wrong, fourth is wrong, fifth is wrong, and sixth is wrong. Okay, so this is how hidden Markov model is working. Now you can go into depths of that to see how to optimize the performance of this model, right? So after NER, there is syntax and parsing, done word sense disambiguation. Okay. So guys, are you done with this? If you want, you can take 30 more seconds. Then let's try to move ahead with the next part. So now word sense disambiguation is going to be the next topic. In word sense disambiguation, what basically is going to happen over here is that we are going to spend our efforts in finding out like a single word can have multiple meanings. If I say word orange, does it refer to the color orange or does it refer to the fruit orange? Right? You cannot have any idea unless and until you have the gist of that particular portion. Right? Similarly, if I say mouse, is it the animal mouse or is it the mouse that we use with computers? We don't have any idea, right? So a single word may have multiple meanings, and exactly to which word it is referring to, it is something that you can get only when you are referring to the context of that block, right? So that is basically the main aim for today's session. We can use multiple techniques. WordNet is the technique that we are uh, going to use in our live coding session. But there are other supervised and supervised classification methods that are available. Here are the applications of named entity recognition, text parsing, and word sense disambiguation, which we will see later. So you can take 30 seconds to read this. This is the theoretical introduction, and then we can move ahead with the live coding session for this with WordNet. So now let's try to move ahead with the next part over here. So let's try to have word sense disambiguation, which is WST. Okay. Now over here, what we are doing is, have we done it with WordNet? Okay, done. Perfect. So now after this is done, any questions, doubts that you guys are having? Voting. Feel free to interrupt me, guys, if you are having any questions or doubts. Importing important libraries from nltk.corpus, import wordnet as wn, and from nltk.wordSense disambiguation, import Lesk. It is Lesk's method for word sense disambiguation. Now we are having example sentence over here. Sentence is equal to I went to the bank to deposit some money. Then you have tokenize the sentence. Tokens is equal to NLTK dot word underscore tokenize sentence, and then disambiguate the word bank in the sentence that has been given. So word to disambiguate is equal to bank. And sense is equal to less tokens, comma, word to disambiguate. Take 30 seconds for this and do let me know if you need my help in any section, guys. So guys, after this is done, let's try to move ahead. Any questions, everybody, guys, that you are having? Yes, no, maybe you will have it after the session is done and you study it. Guys, am I audible by the way? Guys, hello? Hello. Yes. Okay. Perfect. So let's continue our analysis where we would be printing the result. So if sense, so print the the sense of the word is sense dot name colon sense dot definition. Else print could not disambiguate the word key. So I think you got the answer. 30 seconds for this, everybody, guys. Just give me 1 second. Text generation is theoretical. Okay. Then what we would be doing over here is disambiguating more words in the sentence. So for word in tokens, sense is equal to less tokens, comma, word, and if sense print the sense of the word is sense dot name sense dot definition. Okay. So with the for loop, I'm trying to do it for all the words. You can also add else statement if you want. Okay, it depends on you what you want to do. So 30 seconds on this, and then we would be moving ahead with text summarization, which would be the last topic for this session. Then we will continue at 2 p.m. with the other topics that are there. By the way, this live coding file is basically something that you are going to get any which way, so don't worry about it. So perfect, let's try to move ahead. I hope you have written this code in your laptop, everybody guys. So now let's try to move ahead with our last section over here for today, which is text summarization, which I think you guys already know there have been questions with regards to this particular point. So in text summarization, what basically happens is that there are first of all different neural networks and different methods that are available over here. So in NLP, summarization of the input data that has been given, classification of NLP problems. Like there are different aspects, but text generation and summarization is like one of the really big aspects of that particular portion. And what is going to happen over here is that in text generation, it's NLP part that involves generating coherent and contextually relevant text to the given input. So let's say if I give a story of 5,000 words and I want to get the gist of that in 500 words, maybe, or 200, 300 words, then that is something which comes in text generation in NLP, and for that there are different language models that are there. As you know, large language models, LLMs. So even for chatbot creation and content creation, ChatGPT is something that you are using for content creation. There, the same logic or the same portion is being used, right? Is it making sense to all of you guys? Perfect. Now let us try to move ahead with the next part over here. Okay. So language models, context training data, you can read it, but then there are different techniques for text generation. So there is n-grams, which uses the probability of the word based on previous n minus words that you have given. It suffers from data sparsity and cannot capture long range dependencies. Then there is RNN, and then obviously LSTMs and GRUs are variants of RNN itself. So it's again, this also struggles with long-term dependencies, but LSTM is very good in capturing data over long-range sequences, right? As compared to RNNs, right? And GRU has a problem that it has a lot of gates. So that problem of LSTM is sorted in GRU. So it can handle, it has a simplified version with fewer gates, which makes them faster, and it can capture long-term dependencies in the data as well. Okay, so these are the techniques, and I hope you guys are pretty much well aware of this particular portion as well. Is it making sense to all of you guys, everybody? Perfect, perfect. So let's try to, you guys can read this much portion. If you have any questions or doubts, do let me know about that. Ngrams, RNN, LSTM, GRU. And definitely then after that, there are transformer models that are available, and we will move ahead with it. But these are the prominent techniques that are there. 30 seconds for all of you guys to go through this. So now let's try to move ahead with the last part, which is transformer models. You know, GPT, generative pre-trained transformers, BERT, bidirectional encoder representation for transformers. So transformers, they have uh, this architecture. There are like two models over there: encoder, decoder, generator, discriminator. And the most advanced concept that is available today in generative AI or deep learning, it's transformer architecture, which we have already discussed, right? So Just 1 minute. Okay, this is my document itself. Then, sir, is there any difference between GPTs and transformer models? Obviously, GPTs are one of the transformer models, a specific version of the transformer model with which we are working. Right? Like GPT is one of them, BERT is one of them. In GPT focuses on GAN in transformer model. So it focuses on generative analysis, right? Okay, 30 seconds on this, everybody, guys, and then I think we would be in a comfortable position. All the topics are done apart from word embeddings, which is a short topic, and text classifications. I think we can cover up all of that in the afternoon session, right? So yes, I think then this is any questions and doubts, all the learners. Are you guys having any questions, concerns, doubts?
So can you please tell us any evaluation metric that can work on semantic analysis? Is there any
Sorry, that can work on
semantic
semantic
analysis?
semantic analysis. Do one thing, you search about it on your own. Try to search about it on your own. And in if you're not able to get anything, I will give you the answer in 2 p.m. session.
Okay.
Okay, even if possible, I will give you the reading material for that metric.
Sure, sir. That will be helpful.
Okay. Perfect. So let's do one thing. Let's wrap up our session over here and let's resume at 2 p.m. then. Okay. Harshvardhan sir, you are there? Hello. Mm, hybrid model in what context? I mean, there are different contexts for that. So, I mean, in supervised and unsupervised hybrid model is a semi-supervised model. Exactly in which context you are asking. So do let me know that uh, part, Lakshmi, and then I will answer this. Okay. Sentiment analysis hybrid model. So what basically happens is that first of all, in sentiment analysis, it's kind of like a classification model, right? That out of the pre-trained available sentiments, you try to see what is the exact sentiment. But the hybrid model concept in sentiment analysis basically revolves around the fact that it's not only doing the classification part, it is also trying to get the textual analysis, like the syntactic analysis and semantic analysis, that what's the exact problem. So from the harsh words, you can get that whether it is negative or positive. But in hybrid model, you also get the root cause of the harshness and everything. Okay, perfect. Anybody else, guys?
So one more question.
Absolutely, tell me.
Let's say in transformer model, we have a very important component that is attention mechanism.
Sorry, let in transformer model, let's say.
Sir, in transformer model, we have a very important component that is attention mechanism,
Absolutely, attention
right?
mechanism. Yes, yes.
So can we add this particular attention mechanism in sequence to sequence?
It see basically what happens is you can add it definitely, but the thing
Uh-huh.
is it's not pre-coded. You will have to manually write the code for scratch for it. So what
Okay.
people do is that they import they create a what you can say uh, hybrid model is the correct word used by Lakshmi. So they use the transformer architecture to generate the things, and then they superimpose that later thing which you said, right? So
Okay.
it's not pre-coded. The disadvantage is that it's not pre-coded. You will have to write the function for it from scratch. But good part is it can be implemented. Absolutely, it can be implemented.
Okay. Thank you, sir.
Yes, no problem.
Hello, sir.
Yes, hello.
Hello,
Yes, yes, hello, hello.
sir. Good afternoon, sir.
Good
Sir,
afternoon.
is ChatGPT using using any kind of data set, sir?
Absolutely, it's a pre-trained model. ChatGPT is a pre-trained large language model, and it has been trained on millions of tokens or textual data all around the internet that is present. Absolutely. So any ML, any model in AI, if it is doing something, it means that it has been trained on something.
Okay, sir. Thank you, sir.
Absolutely, it's trained. Absolutely, 100%.
Okay, sir. Thank you.
So I think Dr. Harshvardhan is not here, maybe because of which feedback form is not available, but you will get it. Don't worry about it. We will circulate it in the chat.
We will post in the group, sir. We have
Okay,
a
okay,
WhatsApp group. We will post it in that.
okay. Perfect, perfect. So thank you guys. Let's wrap up and let's resume at 2 p.m. then.
Thank you, sir. Thank you very much.
Thank you everybody. Bye.